Hello and welcome to our next section, continuing section of area for quadrilaterals. We're working now with trapezoids, kites, and rhombi. If you're wondering why a rhombus makes a second appearance, is because a rhombus is technically a kite. So that means we could use the kite equation. And if you also remember, a square is also technically a rhombus, which means it is also technically a kite. So you could actually use this new equation for squares as well. So we'll talk about that. Areas of trapezoids. If you remember, everything is all of our area equations are based off of the rectangle. So if we could somehow piece this together so that it resembles a rectangle, then we could actually work with it. So that's what I'm going to do for both of these, the area of a trapezoid. For instance, if this is an area of a isosceles trapezoid, this is actually very easy to visualize. If, for instance, if we compartmentalize this into two triangles and a rectangle, in this particular case it's a square, but a rectangle still, we could cut this piece out. And what I'm going to do is I'm going to cut this off. I'm going to rotate it 180 degrees so that it kind of resembles this triangle instead. So we'll rotate it around. And what happens if I rotate this triangle to the far left side? Well, this new shape that gets cut out becomes a rectangle in blue, because that piece on the far right is now cut out, and we actually have a rectangle that we could work with. The area of this rectangle would be 3 units times 4 units. Okay, 3 times 4 is 12, so we should know that this area of this trapezoid is 12 units. But how can we actually calculate that with the given pieces of a trapezoid? For instance, if I didn't want to cut that out every single time, what we could do is we could actually find the average of the bases. Base 1 here is a top base, is 3. Base 2 has a unit length of 5. So the average of those two is 4. 4 times the height, which we could count. Wow, that's a terrible line. 3 units here. We could actually calculate this out. The average of 3 and 5 is 4. 4 times the height 3 is 12, just like we calculated with the resemblance of a rectangle. So the area equation is actually, there are 2 versions of it. So I'm going to put the 3 here, 3 units, so we could write this inside. Area is equal to the average of the bases, base 1 plus base 2, all over 2, times height. Or you could write it as area is equal to 1/2, in parentheses, base 1 plus base 2 times height. They are both technically correct, and they both work, as we just saw. I'm going to use the bottom equation, 1/2 times 3 plus 5, because they're your 2 bases, times the height of 3 units. 3 plus 5 is 8. 8 times 1/2 is 4, times 3. So we get area is equal to 12 units squared. So either equation works here. Okay. Now, kites are slightly different. If you really want to see this as a rectangle, you could actually draw a giant rectangle out of this. And we have one. And I don't know why it keeps doing a square, but hopefully you get the idea. So let's do this, and let's try this. Pink. You do not have to copy this down, but if you notice, this is just a big rectangle. If you also notice, from each diagonal represents the length and the width, or the base and the height. So if you really, really look at this, we have a base and a height of the pink rectangle. But the pink rectangle isn't the diamond. The pink rectangle is actually a whole bunch of half rectangles. So what we need to do is, if we're actually calculating this piece of this, we're actually calculating a triangle. Same thing here, same thing here, same thing here. If you remember your equation for a triangle, it's 1/2 base times height. So that's actually what we're going to do here. We're going to calculate the area of this rectangle, but we're going to actually cut it in half, because we're actually we're cutting out all of these extra pieces. So the area equation for a kite is as follows. Area is equal to 1/2 times diameter 1 times diameter 2. And that's it. Okay? So let me clean that up just a little bit. I'm going to erase all of these pink parts because we don't need them. That's just for the visualization of it. Area should be equal to 1/2 times diagonal 1 times diagonal 2. In this particular case, we could actually calculate this. Diagonal 1, we could call that 4. Area is equal to 1/2 times 4. 1, 2, 3, 4, 5. So we could say 5. Diagonal 2 is 5. And we could say area is then equal to 10 units squared. And this applies to both rhombi, squares, rhombi and squares as well. So including rhombi and squares, because they are technically kites. Okay, if you don't believe me, we could do one really quickly. Let's do a square, because if it fits as a square, then it should fit as a rhombus as well. So let's say this has 3 units, or 3 inches, which means all sides are 3 inches. If you remember your diagonals for 45, 45, 90, this makes it a lot easier, which makes this 3 root 2. Diagonal 2 would also be 3 root 2 because they're congruent, property of a rectangle. So area would then be equal to 1/2 times 3 root 2 times 3 root 2. Okay, so if we did this normally, we would just say the area of this is equal to 3 times 3, which is equal to 9 inches squared. If we did it here using the diagonal equations, we should be able to piece this together. 3 times 3 is 9. Root 2 times root 2 is 2, but don't forget the 1/2 there. So area is then equal to 1/2 times 2 is 1, so we're just left with 9. 9 inches squared. So they work, they both work. Okay, it's easier obviously if you have the diagonal. If the 3's, for instance, were gone from this, then you would use the diagonals. All right, if you do have any questions, please let me know, and I'll see you in the next one. Bye.